Hello, space enthusiasts and curious minds. Today, we're diving deep into the red sands of Mars with the latest findings from NASA's Perseverance rover. If you've ever wondered about life on other planets, this video is for you. Stick around as we explore groundbreaking evidence that might just redefine our search for extraterrestrial life. The quest to uncover extraterrestrial life intertwines with fundamental sciences like biology, geology, and chemistry, illuminating our existential questions about the cosmos. This exploration was thrust into the limelight last month when NASA's Perseverance rover made a groundbreaking discovery on Mars. On July 21, Perseverance analyzed an arrow-shaped rock dubbed Chayava Falls, named after Arizona's tallest waterfall in the Grand Canyon. This Martian rock revealed organic compounds, the elemental ingredients for life as we understand it. Streaked across this rock are veins of calcium sulfate, suggesting that fluids, likely water, once meandered through its structure. Even more compelling are the rock's white spots surrounded by black rims, where the rover detected iron phosphate molecules. On Earth, such markings are often linked to the fossilized remnants of microbes. On Mars, these could indicate ancient chemical reactions that might have fueled microbial life billions of years ago, according to a NASA statement released on July 25. These collective characteristics of the Chayava Falls rock represent a potential biosignature, a tantalizing hint that it once harbored conditions conducive to microbial life. While the Perseverance team is buzzing with excitement over these findings, they caution that no fossilized life forms have been identified. It's also important to remember that Perseverance is not equipped to conclusively detect or confirm alien life. Instead, it's gathering scientifically significant samples that will eventually be brought back to Earth for detailed analysis. Could the Chayava Falls rock hold the answer to a timeless question that has captivated humanity ever since we first gazed at the stars? Are we alone in the universe? This profound query might find its resolution much closer to home, possibly within the next decade, if NASA's ambitious Mars sample return mission overcomes its current hurdles and successfully brings Martian samples back to Earth. Here, in specialized laboratories, scientists will have access to far more sophisticated instruments than those aboard Perseverance, allowing for an unprecedented level of analysis. The implications of discovering extraterrestrial life are monumental, completely transforming our understanding of the universe, explained Amy Williams, an astrobiologist from the University of Florida and a member of the Perseverance science team, in a recent interview with Space.com. It's a discovery that, once made, changes everything. There's no going back. This is by far the most striking detection of organic signals that the rover has encountered, notes the team. The presence of organic carbon is a crucial marker for identifying intriguing samples. After all known life on Earth is carbon-based. However, it's vital to remember that organic carbon can also arise abiotically without the presence of life through geological processes or from meteorites that have landed on Mars throughout its history. The texture of the leopard spots on the rock is particularly fascinating. These spots are circular patches of a white mineral with a dark mineral rim. Our instruments have identified iron phosphate within these features, which on Earth are often linked to microbial life. Such textures, showcasing contrasting oxidation states in close proximity, are exactly what catch our eye. They suggest potential energy sources that life could exploit. Moreover, we've observed calcium sulfate veins cutting through various Martian rocks. This likely indicates that fluids once flowed through these rocks, leaving behind mineral deposits. We've just navigated away from a delta fan structure, confirming the presence of water in Mars' ancient past. Taken together, these clues paint a picture of an environment that was once habitable. Certain features mirror those associated with microbial life on Earth, fueling our excitement and driving our desire to delve deeper into these Martian rocks. The suite of instruments aboard Perseverance is designed to carefully select samples for return to Earth, rather than to detect life directly on Mars. the implications of finding life on Mars spark widespread debate among scientists and philosophers alike. The discovery would be revolutionary, shifting our understanding of life in the universe. Because of its profound impact, there's a consensus to approach such claims with extreme caution. Once we declare extraterrestrial life discovered, there's no turning back. That's what makes the current mission so exhilarating. We're presented with a rare opportunity to investigate and possibly uncover evidence of life beyond Earth. While Perseverance itself isn't equipped to confirm such findings, the analyses we'll conduct back on Earth could. For the first time in the history of Mars exploration, we stand on the brink of potentially confirming ancient life on Mars, marking a thrilling chapter in our quest to understand the cosmos. There's a palpable buzz among the team whenever we stumble upon something as intriguing as this rock sample. It injects a new vigor into our work. Each sample we gather offers a window into Mars's past, but this particular find has been particularly inspiring. It prompts a reflective pause to consider the extraordinary work of our team and NASA's broader achievements on Mars and other celestial bodies. It's moments like these that underscore the thrilling journey we're all a part of. As we delve deeper, we're piecing together the environmental story of where this sample originated. Found at the junction of two distinct rocks, we're investigating their relationship. It's unclear if these rocks were subjected to heat, which could have altered their elemental makeup. Nearby, veins filled with olivine, a mineral typically formed in magma, raise further questions. Did these come from further up the valley? Are they remnants of a primary geological process, or are they transported materials? And if this environment once harbored magma, how does that align with the presence of organic carbon, possibly biological in origin? These are the complex puzzles we are eagerly working to solve. Our mission's ambition has always been to collect the most compelling samples from Mars to explore deep and complex questions. This endeavor is far from straightforward indeed. It presents a multitude of questions that could occupy scientists for multiple lifetimes. To delve into the mysteries of organic carbon, for instance, there are myriad techniques beyond the current capabilities of Perseverance. Through mass spectrometry analysis, we hope to unveil intricate details about the organic signals detected by SHERLO, one of the rover's key instruments. These analyses could lead us to conclude whether such complexities could only be the handiwork of life or resemble abiotic processes known to us, like those found in meteorites, or they might leave us pondering still. Bringing these samples back to Earth opens up even more possibilities. Depending on their composition, we could determine their ages, shedding light on the history of water on Mars, and potentially when life might have existed there. Each pathway leads to further hypotheses and broader implications. This is just a glimpse into the realm of astrobiology, one slice of the vast scientific pie that excites me. Imagine the wealth of knowledge we stand to gain from these samples once they return to Earth. The notion of encountering forms of life, unlike any we know, is a thrilling possibility, especially on a planet as Earth-like as Mars. The challenge for scientists is to discern whether the evidence leans toward biological origins or is purely the result of non-living processes. Often, the most perplexing scenario involves indications of both, leaving us in a realm of ambiguity. This complexity is the very essence of scientific inquiry. Do we possess a definitive guide to distinguish between biological and abiotic phenomena? Absolutely, but it's continuously evolving. Bringing Martian samples back to Earth could dramatically shift scientific focus toward unraveling these ambiguities. The samples from Jezero Crater, in particular, might redefine our approach to these mysteries, enhancing our ability to make precise distinctions between life-driven and non-life processes in our analyses. This pursuit to refine our understanding of the Martian samples could lead to groundbreaking insights about the planet's past. The rover is performing spectacularly as we wrap up our exploration at the edge of Jezero Crater. Our next ambitious goal is to ascend from the crater and venture into the ancient Noachian terrain a region from one of the earliest Martian eras, rich with historical water activity. This journey into a period not yet studied on the ground is thrilling. This sense of adventure fuels our team's enthusiasm and underscores the significant contributions we're making to science. It also sparks tremendous inspiration and hope for the future generation of scientists. I recently spoke to a group of high school students and told them, "You are the perfect age to be the future scientists who might work on these samples." The thought is simply awe-inspiring. Though small in size, the significance of these samples is monumental. They promise to revolutionize our understanding not only of Mars, but also of Earth and potentially exoplanets. They open doors to questions we've yet to even conceive. The potential for discovery is boundless, hinting at the untold stories these samples will reveal to many future generations. The Perseverance rover, NASA's most advanced rover yet, landed on Mars in February 2021. Its primary mission: to search for signs of ancient life and collect samples of rock and regolith, broken rock and soil, to possibly return to Earth. But what makes Perseverance different from its predecessors? Equipped with cutting-edge scientific instruments, this rover can conduct an unprecedented analysis of the Martian surface. Let's unpack the tools and technology on board that could uncover the secrets of Mars. Recently, Perseverance relayed exciting data from Jezero Crater, an area believed to be an ancient river delta. The findings? Organic molecules in rock samples. While organic molecules are not conclusive evidence of life, their presence is a significant piece of the puzzle. These molecules are the building blocks of life on Earth and could point to past microbial life on Mars. We'll break down why these findings have scientists buzzing with excitement. The discovery of organic compounds on Mars has profound implications for the field of astrobiology. Astrobiologists study the potential for life in the universe, not just on Earth but everywhere. The presence of these molecules suggests that ancient Mars could have had environments conducive to life. What does this mean for our understanding of life's universality? We're closer than ever to considering the possibility that life could exist under conditions vastly different from those on Earth. Despite the exciting prospects, skepticism remains. Detecting organic molecules is not proof of life. It only indicates the potential past presence of life. The Martian environment presents extreme challenges for microbial survival, including harsh radiation, cold temperatures, and thin atmosphere. How do scientists approach these challenges, and what methodologies are in place to ensure accurate interpretations of the data? Let's discuss the rigorous process behind these scientific conclusions. Looking ahead, the journey of the Perseverance rover is just one step in a long-term scientific strategy to unravel Mars mysteries. Future missions might focus on returning these samples to Earth for more detailed analysis. What could we learn from such studies? The potential discovery of past or present life on Mars could open new avenues for research and perhaps, one day, manned missions. Jezero Crater, once home to a river delta, was chosen for Perseverance's landing site because of its rich geological history. This area is believed to have been filled with water billions of years ago, creating a perfect environment for life as we know it. Understanding the history of Jezero Crater helps scientists pinpoint where to look for signs of ancient life. Imagine a Martian lake teeming with microbial life. This is the picture scientists hope to paint with their findings. One of Perseverance's key instruments is SHERLO, scanning habitable environments with Raman and luminescence for organics and chemicals. This tool is designed to detect organic compounds and minerals that form in watery environments. SHERLO uses a laser to identify these compounds, providing critical data on the composition of Martian rocks. This segment will delve into how SHERLO operates and why its findings are crucial for the mission's success. Perseverance is equipped with a sophisticated system to collect and store rock and soil samples. These samples are then sealed in tubes and stored on the rover for potential future return to Earth. The process involves drilling into the Martian surface and extracting core samples, which are then analyzed for their chemical and mineral content. This segment will explore the step-by-step process of sample collection and the technology behind it. The thin atmosphere of Mars presents a unique set of challenges for both robotic and potential human explorers. Composed mostly of carbon dioxide, the Martian atmosphere lacks the density to support liquid water on the surface. This segment will discuss how Perseverance's findings about the atmosphere could inform future missions, particularly those involving human exploration. Understanding the atmosphere is crucial for designing life support systems and habitats. Water is a key ingredient for life, and the presence of water on Mars, even in its ancient past, is a significant focus of the Perseverance mission. Scientists believe that by studying the geological formations and sediment layers in Jezero crater, they can determine the history of water on Mars. This segment will look at the evidence for ancient lakes and rivers on Mars and what it means for the possibility of life. Astrobiology is the study of life in the universe, and Mars is a prime candidate for astrobiological research. The discovery of organic molecules and other potential biosignatures on Mars has profound implications for our understanding of life's potential beyond Earth. This segment will delve into how these findings fit into the broader context of astrobiology and what they could mean for future discoveries in our solar system and beyond. One of the most impressive features of the Perseverance rover is its ability to operate autonomously. Equipped with advanced navigation and hazard avoidance systems, Perseverance can make real-time decisions about where to travel and which samples to collect. This segment will explore the technology behind Perseverance's autonomous capabilities and how it enhances the mission's efficiency and safety. Accompanying Perseverance is the Ingenuity helicopter, a technological marvel that has achieved the first powered flight on another planet. Ingenuity's successful flights provide critical data for future aerial exploration of Mars. This segment will discuss the achievements of Ingenuity, its contribution to the mission, and how aerial reconnaissance can aid in the search for signs of life. Geological mapping of the Martian surface is a key aspect of the Perseverance mission. By studying the layers of rock and sediment, scientists can reconstruct the planet's geological history and identify areas that may have been habitable. This segment will explain the techniques used for geological mapping and the significance of these findings in the context of the search for life. Organic molecules are the building blocks of life, and their discovery on Mars is a tantalizing clue in the search for ancient life. This segment will delve into what organic molecules are, how they form, and why their presence on Mars is significant. We'll also discuss the various hypotheses about how these molecules might have been preserved in the Martian environment. Meteorites from Mars that have landed on Earth provide another valuable source of information. Some of these meteorites contain organic compounds, similar to those found by Perseverance. This segment will explore the connection between Martian meteorites and the rover's findings, highlighting the complementary nature of these research avenues. Exploring Mars is no easy feat. From the harsh environmental conditions to the technical challenges of operating a rover millions of miles from Earth, each aspect of the mission requires careful planning and execution. This segment will discuss the major challenges faced by the Perseverance team and how they've overcome these obstacles to achieve groundbreaking discoveries. Perseverance's mission is paving the way for future human exploration of Mars. The data collected by the rover will inform the design of habitats, life support systems, and other critical technologies needed for human missions. This segment will discuss the implications of Perseverance's findings for the future of human space travel and the exciting possibilities that lie ahead. The search for life on Mars is a global effort involving scientists and researchers from around the world. International collaboration enhances the mission by bringing diverse expertise and perspectives to the table. This segment will highlight the contributions of international partners to the Perseverance mission and the importance of global cooperation in space exploration. As we look to the future, the Perseverance mission is just the beginning. Upcoming missions aim to bring samples back to Earth, conduct more detailed analyses, and eventually send humans to the red planet. This segment will explore the exciting prospects for future Mars exploration and how Perseverance is laying the groundwork for these ambitious endeavors. One of the most anticipated future missions is the Mars Sample Return (MSR) mission. This ambitious project aims to bring back samples collected by Perseverance to Earth for detailed analysis. These samples could hold the key to understanding Mars's geological history and the potential for past life. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.